Hello everyone. Let us discuss about the construction of the character table for C3v point group in this presentation. Before going into that, let us have a recap of the rules which are dealt in great orthogonality theorem, which are going to be used for the construction of the character table. So the first rule says the number of irreducible representations in a group will be equivalent to the number of classes in a group. Or else, how many classes are there? That many irreducible representations will be resulting out. Then comes the sum of the squares of the dimensions of the representation will be equivalent to what? The order of the group. The sum of the squares of the characters of any irreducible representation again will be equivalent to order of the group. Then to evaluate the characters of other irreducible representations, the characters of two irreducible representations or any two irreducible representations should obey the orthogonality condition. So these are the rules that was actually discussed elaboratively in the previous presentation. Next, let us just take into account the various steps that are to be taken for the construction of the character table. Okay, so the first step, you have to write all the symmetry elements of the point group and you need to group them into the class. After finding the number of classes, then we will be getting the total number of irreducible representations. Okay, once the classes are obtained, how many classes are there? That many irreducible representations are actually assigned. Okay, so that is the second step. Then the third step, we are going to find out the dimensions of the irreducible representations using the above theorem. So what is that? Dimensions of the irreducible representation should be equivalent to what? Order of the group. So that is what in third step. The next step, the other characters of other irreducible representations, characters can be found using the orthogonality or normality conditions. Okay, so that is what it is used for fixing the characters of other irreducible representation. While calculating for degenerate group, care has to be taken where the number of symmetry operations in each class has to be considered. Then finally, the complete character table can be obtained by generating the representations using the basis vectors such as x, y, z, rx, ry, rz, etc. So that we will get the complete character table. Okay, then let us just move on with the C3v point group. So as it was discussed, stepwise let us follow in order to evaluate. Okay, so first step. So what is a point group? Here we have taken it is C3v. So according to that, what is the first step? Symmetry elements you need to write down. So C3v, which is actually belonging to which molecule, which is most often or commonly used example, it is ammonia, H1, H2, and then H3. Okay, so it will be having trigonal pyramidal in shape, which will be having C3v point group. So the various symmetry elements which have been evaluated for this molecule are listed over here. E, identity, then it will be having C3, since it has the base trigonal, so C3 1, then C3 2, or else it can be C3 inverse. This is also it is equivalent to C3 2. Then comes 3 plane of symmetries, so sigma V passing through H1, sigma V prime, then passing through H2, sigma V double prime, the plane passing through H3, sigma V triple prime. So these are the symmetry elements which have been listed. Now we need to group them. So grouping has to be done using similarity transformation. So let us group over here. So this belongs to a separate class. Which one? Identity. E. Okay. Then these are actually grouped together. Okay, these two symmetry operations are grouped, which was actually proved using similarity transformation. So it could be written as 2C3, and these three are again grouped, and that is again 3 sigma V. So these are the groups which has been classified as class. So the number of classes here, number of class, here it will be what? 3. 3 classes. Okay, and order of this point group. Okay, order of the point group H. How many total symmetry operations you have? 1, 2, 3, 4, 5, and then 6. So order here it will be 6. Okay, so these are the basic information regarding this point group that we have written. Now, the second point, the total number of irreducible representations equal to the total number of the classes. So we have listed the classes over here in this table E, 2, C3, 3 sigma B. How many classes are there? That many irreducible representations would be there. So here it comes 1, 2, and 3 irreducible representations we have. So that is according to the second rule. That is the second step. So second step, number of irreducible representations will be equivalent to the number of class. Okay, so number of classes are actually 3. So irreducible representations will be 1, 2, and then 3. So these are the 3 irreducible representations. Okay, so we have got this one and we have written this table. The next we are going to evaluate the dimensions or the characters of the irreducible representation. So the third step, what is that? Determine the dimensions of irreducible representation. Okay, dimensions of the irreducible representation using the theorem. So from the orthogonality theorem, the dimensions of the irreducible representation again will be equivalent to what? The order of the group. Okay, so let us see then. So third step, the dimensions. Okay, the dimensions we are going to evaluate the dimensions of the symmetry operation, that is E. Symmetry operation E. Okay, so the dimension of the irreducible representations are actually obtained from the characters of the symmetry operation E. Okay, now here the sum of the squares, okay, the sum of the squares of the dimension, the sum of the squares of the dimensions of symmetry operation. Okay, symmetry operation E should be equal to what? The order of the group, that is H. So let us take, so this is the 1, 2, and 3 irreducible representation. Let us consider the dimension should be L1, L2, and L3. So here L1 square plus L2 square plus L3 square. Then what is the order of the group over here? It is 6. So this is satisfied only if we consider L1 to be 1. So 1 square, L2 also to be 1. Okay, then L3 it should be 2. If you take then 2 2s are 4, 5, and then 6. Okay, so we have evaluated the dimensions of the point group. That is the dimensions of this group. Okay, symmetry operation. So here comes irreducible representation 1, 2 and 3. We have evaluated L1. Okay, we have evaluated for L1, L2 and L3 as 1, 1 and then 2. So this is what the third step. The next step, we are going to evaluate the other characters of the irreducible representation. So for which, let us consider here A1, B1, A2, B2, A3, B3. So what about the next step? What is the next step? Use the orthogonality theorem in fixing the characters. Otherwise, we could say the square of the characters of any irreducible representation again should be what? Order of the group. So let us just take, using that rule, the square of the dimensions of the, okay, the next fourth step, the square of the dimensions or the characters, okay, or the characters of any irreducible representation. So in this case, let us take the first irreducible representation should be equivalent to what? Order of the group, and that is actually 6. Okay, so here for, let us, as we said, we are going to consider this one first irreducible representation. So what are the dimensions or characters? We have already found the first character to be 1. Okay, so 1 square plus A1 square. Okay, A1 square. So in this case, we are going to multiply with the number of operations in each class. So how many operations are there in this class? So 2 operations, okay, 2 operations are there in this particular class. So we need to multiply by 2 here. So 2 plus, we need to take the number of operations in each class. So the next 3 sigma v. So we are taking 3 and the character, it is B1 square. And it should be equal to what? 6. Now tell me, here this will be satisfied only if we consider A1 is equal to 1 and B1 is equal to 1. Then it gets satisfied. So what you get here? 1 square plus 2 into 1 square plus 3 into 1 square. So what do you get then? Okay, so it will be 1 plus 2 plus 3 and that is equivalent to what? 6. Okay, so we have evaluated for A1 as well as B1. So let us just write over here the irreducible representation 1, 2, 3, L1, L2, L3 as 1, 1, 2. Then for first irreducible representation, we have evaluated A1 to be 1, B1 to be 1. Okay, the other things let us retain as such A2, B2, A3, B3. Okay, now we need to calculate or find for other 2 irreducible representations using great orthogonality theorem. Okay, that is the orthogonality condition. Let us, so here comes the next step, the fifth step. So using the great orthogonality theorem, we are going to fix the characters of other irreducible representations. So all the operations, okay, all the operations should be following what? Or obey, or it should satisfy Yeah, orthogonality condition. Okay, so what is that? How do you do then? So here comes summation, okay, of all the symmetry operations. So we multiply with the GP. GP stands for number of operations in each class. Okay, GP. Then here it is the irreducible representation, ith irreducible representation, the character of ith irreducible representation of any symmetry operation multiplied by the character of jth irreducible representation belonging into any symmetry operation should be equivalent to what? 0, orthogonal. It should be 0. So as I said, what is GP? Okay, it is the number of symmetry operations in the class. Okay, now let us try out for the other irreducible representations. Okay, so here we are writing again 1, 2 and 3. We have evaluated 1, 1, 2 and here it is 1, 1 and here it is A2, B2, A3, B3. Okay, under this first step, if we are considering example, first irreducible, the product of the first irreducible representation and second irreducible representation, we take it. So according to this formula, the first, we are going to consider the various symmetry operations E, C3 and sigma V. So GP, what is GP here? Number of operations in each class. So what is the number of E over here? It is 1. So 1 into, then what is the value, the character of the first irreducible representation under E? The character of first irreducible representation under E. So this is the 1. So 1 into 1 into 1 into the character of the jth irreducible representation, that is the next irreducible representation under E. This one. So 1. So this is done. Okay. For E. Okay. This is for E. Plus the next step for C3. We are going to consider for C3. So C3, what is GP over here? How many C3s are there? So GP for this one, it is 2. That is for C3. So GP is 2 into, then what is the value for this one? That is the first irreducible representation character under C3. It will be what? 1. So here it comes 1 into, the next we are going to take into account the second irreducible representations character under C3. So this is the one, A2. So here we are going to take A2. Okay, so hope you are following. Then comes plus, we are going to consider sigma V. What is GP for sigma V? So in this case, GP for sigma V, it is actually 3. 3 sigma V's are there. So GP is 3 into, so what is the character for first irreducible representation under sigma V? It is 1. Then under for the second irreducible representation under sigma V, it is what? B2. We take into account B2. Okay, that's how. Then that should be equivalent to what? We are going to find, or we are going to equate that to be 0 so that it follows the orthogonality or orthonormal condition, orthogonality condition. orthogonality condition that has to be equivalent to what? 0. Now you have to evaluate 1 plus 2a2 plus 3b2 equal to what? 0. So this can be satisfied only when we consider a2. Okay, let a2 be equivalent to what? 1, and b2 will be equivalent to what? Minus. If you consider this, then the above will be satisfied. So as we have said, a2 is equal to 1 and b2 equal to minus 1. So we just list out here. So it will be 1, 1 and 2. Okay, 1, 1. A2, now we have said it is 1. B2 will be equivalent to what? Minus. Okay, the last step, we are going to evaluate A3 and then B3. Now we take up an example of the second and third. Second and third, or we can also take the first and third. Any one we can take. So let us take first and then second. So irreducible representations. 1, the product of 1 and 3. That should obey orthogonality theorem. Orthogonality, that is, it should be orthogonal. Again, now for E, according to the formula, GP it is 1. The character for E under 1 it is this one, 1 into the character for E under third irreducible representation it is 2 plus for C3. So what is GP over here? GP it is 2 and here again it is 1. Okay, and here it is A3. A3 we are going to evaluate. Then sigma V. So what is GP? 3. So here it is 1. Okay, into B3 product B3, and all should satisfy what? Orthogonality condition 0. So what do you get here? 2 plus 2A3 plus 3B3 equal to what? 0. So this is possible only if we consider A3 should be what? Minus 1. Okay, if we take minus 1 here, A3 equals minus 1 and B3 should be equivalent to what? 0. Let us see then. So 2 plus 2 into minus 1 plus 3 into 0. Let us see, are we getting that? So 2 minus 2 plus 0. So that should be equivalent to what? Or that will be equivalent to what? 0. Hence satisfied. So we are going to summarize over here. First irreducible representation, second, third, 1, 1, 2, 1, 1. Then here it is 1, minus 1. Now A3 is minus 1. B3 is what? 0. So this is what the character table that we have got it using those rules. Okay, using the theorems, we have fixed the characters of irreducible representations. So what is the next step? We are going to assign. Okay, so I hope this is the 6th step. Okay, assigning the Mulliken symbol. So Mulliken symbol for the irreducible representations 1, 2, and then 3. Okay, so 1, 2, and then 3. So 1 it is one dimensional. So if it is one dimensional, it should be A or B. So that is the first step. Similarly, the second one also it is one dimensional. Okay, since it is one dimensional, we are getting A or B. A or B, since it is of one dimension. Means we have to consider under E. Okay, what is the dimension, what is the character? And for the third irreducible representation, 2 is the dimension, that is 2 dimension. If it is 2 dimension, we need to assign E. So this is done. Now A or B, then we are going to see with respect to the principal axis of symmetry, that is the C3. So symmetry with respect to C3. Since it is plus 1, then we are going to assign A. Okay. Similarly, the next symmetry with respect to C3. Here again it is plus 1, the character. Okay, this is the 1 plus 1. Then here again we are going to assign A but not B. Okay. Then E will stand as such. Then comes the subscript. Okay, what subscript it should come? Then you have to see the symmetry with respect to what? Sigma V. Then it should be 1. Okay, if it is symmetric with respect to sigma V, we are getting here plus 1. Then that should be equivalent to what? A1. Similarly here, symmetry with respect to sigma V, it is antisymmetric actually. That is, it is antisymmetry with respect to sigma V minus 1, then that should be 8. So here it comes A1, A2, and then E. Okay, so finally we have evaluated the character table for C3v point group. The Mulliken symbols have been assigned A1, A2, and then E. Okay, with all the characters of, by fixing the characters of the symmetry, irreducible representations. And further, we can perform the symmetry operations on various vectors, as we said, for x, y, z, as well as the binary products. Then we can also get the irreducible representations for these bases. Okay, so that can be evaluated, and that actually can be seen in a separate session. But here we are summarizing here. So on performing the symmetry operations on Z vector as a base vector, then we'll be getting the irreducible representation, the character to be 1, 1, 1. So we are just writing over here. Similarly, here we get the rotational vector along Z, then x, y. Okay, then comes Rx, okay, Ry. Then when we take the binary product or squares of the vectors, so Z square, we get over here. Then here the binary product xy, xz, then comes yz. So these are the various symmetry operations performed on these vectors also will lead to these characters of the irreducible representations. Okay, so this is the final character table that we have obtained for C3v point group.